As in diagram, depth coupled model can be represented like this. So inside we have depth atomic model. However, atomic model's outside part is the coupled models diagram. So inside you don't have to write down all the atomic models like this. Okay, it can be just a black box model. And the external input detection will be coming in as an information. And decision output will be coming in as like this is not being specified but decision. And decision of detection, inputs of the decision to the detection model will create the detection output. Okay? So here, this is a decision-making model like the head, okay, brain. And the brain controls detection model by sending decision to detection, maneuver, and engagement model. And they will create individually map to as what? As an EOC, external output coupling, to the outside world event. Here, input is going to be what? Input is going to be all mixed up as an information to be processed by the brain decision-making model. Okay? So this one has its own state, this one has its own state, this one has states, this one has states. Meaning that these states can coexist together, right? For this model, a certain state is set. For this model, a certain state is set. Set. It means that detection model, wait, maneuver, action, engagement, action, that is feasible. All action is being feasible. Because each of the atomic model has the states. So the states, the total number of states, of feasible states, will be what? 3 states multiply 2 states multiply 2 states multiply 2 states. So these many states exist as a combination effect in this depth coupled model diagram. So these are the inputs, these are the outputs, and these are boxes are model, and external input coupling, external output coupling, and finally here, this will be what? Internal coupling. So if we develop from this original model of the soldier, what will be the result? So here, a soldier model can maneuver, detect, and engage at the same time, so supports the simultaneous behavior because the coupled model state will be the combination of 4 models. Here, 1, 2, 3, 4. We already calculated that, right? Here, the central coordinating model will be the here decision-making model. Okay? Having said that, I want to focus on this. Here, the previous soldier's behavior model, we have 3 inputs and 3 outputs, right? And here, this soldier model still has the same X, same Y. Then my question is this. Is it feasible to take out this soldier model and put another soldier model here? That is feasible. That's the beauty of the depth model, so that you can interchangeably exchange the matching, XY matching models at different resolutions. So this is more detailed model. This is less detailed model. However, still semantically inputs and output events are exchanged, mapped, so that you can utilize in this combat model wider choosing each one of these models. Before I finish the depth model, the explanation, I want to give you one exercise question, ping-pong model. Okay? So here, ping-pong model specifies 1 to 2 depth atomic model, and 1 coupled model as an outmost model of ping-pong. Ping-pong is what? The table tennis, right? So player A, player B. Player A is waiting for player B's ball, and when it receives, player A sends that ball to the player B. And then player B will waiting and then receive the ball and then transition to the send and here. Here, notation is a little bit different. Here, time advance is specified in this way. State. So infinite is infinite here, meaning that it will wait for the to send the ball, and waiting ball will be infinite. Until the ball comes, it will be at the ready state. Okay? Can you come up with a ping pong model in a handwriting with this given schematics, diagrams? I will please pause here at the moment and write down your answer. You did that, right? So let's look into this. So here, depth atomic model can be defined as X receives, input events will be, okay, ball is coming in, receive, okay? And ball is going out, so that send, right? It has an input event and output event. And state will be wait and send, wait and send, wait and send, right? Two states. Initial state will be one player will be sending and the other player will be waiting. Okay? So initial state. And time advance will be sending, it will take just 0.1 second. And waiting will be infinite until the input event comes, I will be waiting. That statement. And here, external transition function is what? Receive. Only the X is there is a receive event, so the receive and send will create what? The send. And also receive and wait will create send, right? And after sending is done, wait. After wait is done, of course it's not going to be feasible, but wait. Okay? And finally, if it is at the send state, the send event will be created. If it is waiting at the wait event, no event will be generated, right? So that's the player's depth atomic model. And now we have two players, A and B. Instantiate these two models with same depth atomic model, and then we have to link it up. How? First, this is outmost model. There is no inputs coming in, no outputs going out, because this is the outmost model. So then X and Y are empty. We have two models, player 1 A, player 2 B. Since X and Y are empty, EIC, external input coupling, external output coupling will be empty. Only P1 will be in internal coupling, meaning that first player A will send, that event will be player B's receive. Send, and here receive. And send, player 2 will send, and player 1 will receive. Okay? So that's the alternated structure to send and receive the ball. So this will create your ping pong model. Let's look into details and create your own ping pong model in the exercise session.